Okay, this is grade 7 looking at Unit 1, Lesson 3. Today's lesson is on making a scaled copy. So the key word there is we are making them. So it's going to take a little bit of drawing and some sketching to make some scaled copies today in our class. In previous lessons we talked about how we can use a scale factor in order to determine or describe a relationship between corresponding lengths, right? So if this was a scale factor of 2, I might double it. Just look at how things are changing, so corresponding lengths in scaled figures. And we're going to use that information to help us draw some scaled copies of some similar shapes or simple shapes on grid paper, off grid paper, and that's what you did in your class today. You began by just doing some mental math to decide the value of something is more or less. So I'm going to skip that part for now, and we're going to go over here to the second part of your lesson just as a review. You had some scaled copies here. I wanted you to draw some scaled copies on the grid paper. And so for figure A or B, it asks you to use a scale factor of 3. And to do that, scale factor of 3 means we're going to multiply the lengths times 3 to make that work. And so to do an example here, let's look at A. So if I did a copy of A, I had a length already of 1, 2, 3. So to multiply that by 3, I would do 3 times 3 equals 9. And so to make my scale copy down here, I'd go 1, let's go here, 1, 2, 3, 4, 5, 6, 7, 8, 9 to have my bottom line there, using just similar colors so I can follow along here. On the vertical, we went up 1, 2, 3. So again, 3 times 3 is going to be 9 again. So I'll continue up 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have that length there. On my top, I had a length already of 2 initially. So with a scale factor of 3, we're going to make it 2 times 3 is 6. So 1, 2, 3, 4, 5, 6. And that becomes our top part. And I can measure the other part, or I just know I'm going to have to connect them anyways. So I can go ahead and just draw my line and connect those two lines together to say there is my scaled copy of shape A. Alright, and you did that for shape A, or you might have done it for shape B, and the same idea. Okay, and then you looked at letters, figure C or D, and it wanted you to use a scale factor of a half, which means you're going to be reducing in size. So if I look at D, half means I'm going to cut it down by half of it, sorry. So in this case, I had a length of this one was 2, so half of 2, or 2 times a scale factor of a half, is going to equal 1. So if I began to draw this shape, instead of going 2 on a diagonal, I would just go 1 on the diagonal. And then if I was to cut the next one in half, I see this one is a 2, so 2 times a half again becomes a 1, and so I have 1 there. And then on the next diagonal, I have another 1, 2, so half of that becomes a 1. On the going down part right here, I have a length of 2, so 2 times a half is going to be a 1 still. So there I am there. And then I had this long diagonal, which was 1, 2, 3, 4, 5, 6. So a scale factor of 6 times a half becomes 6 times 1 is 6 over 2, which reduces down to 3. So on the diagonal line, 3 boxes, 1, 2, and 3. And then what's left is to find my final piece, which was 1, 2, 3, 4, 5, 6 again. And so with a scale factor of a half, we know that our length is going to be 3, 1, 2, and 3. So you work that way to do C's and D's and drop them down by a scale factor of a half. And so that was shape D. Then you moved on to looking about different operations here. And the key thing with the operations was recognizing that there's a difference between multiplying versus adding. And that if we're looking for a scale factor, it's important to remember that we have to multiply. Adding just won't work. And they gave you some examples to start with. For this first picture, they gave you an example and said you had this shape, and there was one person who wanted to do some adding, and another person wanted to do some multiplying. And so when you look at the two shapes, I'm going to just write 36 here so we can see this. This was 36 up top. What was happening was Diego was taking the 36 and basically subtracting 10 from all the lengths. so 30 became a 20, and so on and so forth. The problem with that was that when he went to draw the lines, he had a giant gap in his drawing. Something was missing, because when you when you add or you subtract, it doesn't work out too well. Now Jada, on the other hand, she went ahead and took hers, and we can look to go from a 30 down to a 10 is she's dividing by 3, or really she's multiplying by a third. She's making it smaller, and she did that all the way around. 21 times a third was 7, all the way around, and she ended up with a complete drawing. And so we would say for sure that hers was a scaled copy, and that's because it had a scaled factor of 1/3, that every corresponding length had the same scale factor as the original drawing. And so you discuss that there, and the key thing in discussing there is that you're talking about what was called whether you can use multiplication or addition. And the key thing is that it cannot be additive. You can't use addition in order to determine if something is a scaled copy or not. And so when you moved into question part 2, number 4, it said Andre wonders, it says, I wonder if I should add 4 units to the lengths of all the segments in order to make a scaled copy. Because it says he wants to make a scaled copy of the drawing, so the side corresponds to 4. In Jada's polygon has 8 units in his scaled copy. And so we looked at this picture and said, well, if I want that 4 to become an 8, the question was, do I add 4 to all of them? And based upon the prior drawing, we know that just wouldn't work out. You'd end up with a gap once again. But what should be happening is deciding, how do I go from 4 to 8? Well, that's going to be a multiplication factor of times 2. And so to do that there, if I was to make one like that, I would go ahead and say, well, if that's how that works, then I would make this, instead of 10, I would say 10 times 2 is 20, and I make that a 20. I'd make this a 24, and so on. I'd make that a 14, and right now I'm just kind of just making up some numbers, or my lengths, not measuring it. I'd make an 8, I'd make a 10, and I'd make a 12. So everything would have a scale factor of multiplying by 2. And you could do that by measuring the right way. You could do it by using a ruler, using some graph paper, chart paper, however that might be. So for example, that 4 was 1, so instead of 1, I'd make it equal to 2 centimeters, which is about what I did in my estimation. All right, so that was the idea. You had a ready for more, big question here. The side lengths of a triangle B are all 5 more than the side lengths of triangle A. Can triangle B be scaled copy of triangle A? Question is, if I just add 5 more, could that be a scaled copy? And the thing is, it could be, but it depends on the type of triangle, right? If I had a triangle like this, what we might call a 3, 4, 5 triangle, where that's a 3, that's a 4, and that's a 5. If I add 5 to everything, then I end up with a 9 and a 6 and an 8. I'm not quite sure if that's going to work out too well. Where it will work out for sure is if I have an equilateral triangle. If it's an equilateral triangle, if I'm adding the same to each side because they're equal side lengths, I'm going to end up with a corresponding triangle and a scaled copy. The key thing here in our summary is that creating a scaled copy involves multiplying the lengths in the original by a scale factor. And that's the key concept for today, that you have to multiply the lengths by a scale factor. So to go from a 2 to an 8, I'm going to look at a scale factor, in this case here, of 4. Everything is times 4. 1 times 4 is 4, 2 times 4 is 8, and even 2.24 times 4 ends up with 8.96. So that scale factor is going to be 4. So let's take a look today at some of your homework questions. Homework questions were a little interesting, I thought, because you had to then make some scaled copies using what you've learned so far. So when you take a look at the first one, letter A, it says draw a scaled copy of polygon A using a scale factor of 2. This means we're going to multiply the sides of everything by 2. That's a lot larger. And so we have to figure out, well, how am I going to do that? And maybe you use some patty paper, maybe you use just a note card. There's a variety of ways of doing that. I'm going to use some patty paper to start with. So I'm going to go ahead and first go ahead and just trace this shape like this. So I have my length, got my width, and I have my diagonal working down this way. Now remember we said in a previous lesson that our angles all have to be the same. So I'm going to just keep that in mind as I go forward here. If I take that scaled copy, all right, and I double things, I can go ahead and kind of lift my paper and put a dot underneath that and a dot down here to end up with a couple dots, two dots, a pair of dots, and I can have my length. Now this is the same length, so it's not times 2 yet, but I can have one length there. If I was to measure that, for example, I can see it's a little bit more than 5, and so I can just double it and do it again down below and go 5 and a little bit more. And now at least I know the scale factor there. I've multiplied that length times 2. I can do the same thing with the width. If it happens to be a nice one, which this one does, I can see that it's just about 3. So 3 times 2 would be 6. So if I take my ruler, a 90-degree angle, and come out to the side, about 6, I'm going to end up something like that. And then I connect the dots, and I should be able to line up those 2 points to come up with a triangle that is now a scale factor of times 2. And I'll call this, we call it A prime. I can double check by also looking at my angles. Do my angles fit? Yep, that one fits right in there. And moving down here, that angle should fit right in there snugly, and it does. My picture's not perfect, but you get the idea. Now I have a scale factor of times 2. For the next one, for B, it says a scale factor of 1/2, which means I'm going to be getting making a smaller shape. For this one, it was a little trickier, I thought, because, well, how are you going to do that? It's going to be smaller by 1/2, and when I use like a centimeter ruler, I get like 3.5 there. I'm not really sure what that means. Look here, I have a 4. That's a little bit more manageable, which means, if I have a 4 on this length, on centimeters, and I go by 1/2, I'm going to aim for 2. But I think what's key is to look at this angle as well, because if it's a scaled copy, the angle should be the same. So what I did is I went ahead and began by making a copy of that angle. I'm not worried about the length so much right now, but a copy of the angle. Oh, sorry about that. Copy of that angle. So now when I take that angle, I can then come down here and I can make a copy of that angle. I press kind of hard. I should be able to end up with, yep, there it is. That angle, same angle measurement right there. Now I don't know the length yet. I said before that the length up here was 4, so instead of 4, if I measured this out to about 2 using that same angle, I would extend this line down to 2, and then I would extend this line using the same angle out to about 2. And there we are there. I'm not done yet, because now I still have this other piece on the bottom that I have to figure out as well, right? So I'd figure out, well, how am I going to make that go together? I could look at how tall this is, and we see it's about 4. That might work. I could drop this down and say, well, if I come down about 2, I should end up getting a point somewhere around here, potentially, is what I'm looking at. I could also, another way could be to say, well, what if I take this line, all right, and I'm going to go ahead and go right here on the edge of my patty paper. I'm going to take this line and I draw a line like so, and then I take the line and I fold it in half so that my end points line up with each other. Now I have half of that original length. So when I go to draw that line, I'd end up with something along this distance, which gets me pretty close down there, doesn't it? Right? So I put a dot there to know I'm there to there, and my dot is something about here. The same thing over here, it's about half again, so somewhere around here, and there's my dot again. And the tricky part is I do have that angle, so I could take a look at this angle measurement and duplicate that, and then slide that down there and say, well, where should that be? It should be something like this, so we're pretty close there, and what that should look like, and do kind of an impression, make it a little bit thicker, and I can see it, I'm just about right. So I'm going to leave it like that. It's not perfect, but it's pretty close for a scaled copy of B. C is a similar idea. It's also a little tricky too, because now we have a polygon with a scale factor of 3/2. Now 3/2 is greater than 1, so we're going to be making a larger scale copy. This one also is a little tricky. You do have some angle measurements here, and so I'm going to go ahead and just trace this whole shape out for now, just so I can deal with the angles as they come up later. And so I can trace that there. And I think what's interesting about 3.5, besides it being different, is that 3.5 means it's 1.5 times larger. So it's not doubling it, but it's taking the side, and we're taking half of that side and increasing it. Which means I'm going to take this length, for example, and if I cut it like in half, about here, that means on my new drawing, I should have something like this. I should have a full line. I'm going to draw a nice thick line there, pressing through there, moving that up. See if I can see that little tracing spot, which there it is there. Right, so there's my line, but I also want to have a line that's going to be this long, an extra half of it. So I'm going to go ahead and put that right there. I'm going to notice where we're going to go underneath the paper a little bit, put a point. Now I can extend that additional half measurement right there. So now I have a scale factor for the first line of 1.5. We're in good shape. I want to then take my drawing and get my angle measurement right for what this is going to look like, because I'm going to draw a set of parallel lines in the top and bottom here. So I line it up at the very top, and I can see that my line needs to come out this direction, and I can go ahead and put a dot right here at the edge of this one, because that's going to be right where it's going to be. I can also come down to the bottom and put a dot down here, right about there. So I'm underneath the paper, making a dot underneath the paper. And if I want to kind of press hard, I could press hard and make that dot so I can see it later on. Sometimes it'll go through for you. We can do that. So there's my points. Now I don't have a length yet. I have my initial length, which is one measurement there, but I also want another half of it. So I'm going to draw a line in half and make that my additional length. So for here, because just where it is, I know I'm going to go from here to about here. I'm going to make a little point so I can see through it, and there it is. Again, if I wrote it a little closer to the top, I'd be able to use that as a measurement tool. Again, a note card could work for this too, but I can see it come out to about a half. So that's the initial length here, and then the additional length is here on that same line, using my patty paper to make sure the angle is the same. So I'm going to go ahead and just complete that out. So I get there all the way to there. And then we'll do the same on the bottom. We'll take our paper, fold it in half. It just takes time. It's not like it's just a short little thing. This just takes time. Don't get too discouraged. You can see I'm taking my time too, no problem. And there's my original length plus a little bit more. And so we'll extend that out to make sure we have everything right. I'm gonna go out to here, something like that. And then we'll connect the dots over here and get our shape done. Perfect, hard to say it's perfect, but it's definitely gonna be a scale factor of 3.5. And I can see my angles line up there, measure just fine. They fit inside those shapes, so we did a good job there. So that becomes C prime. Let's look down below, number 2. This quadrilateral A has side lengths of 6, 9, 9, and 12. B is a scaled copy of A, with the shortest length being 2. Well, my original short length was a 6, so I'm going from a 6 times a scale factor to 2. So I'm trying to figure out the perimeter of this shape. Now in my initial perimeter, it's going to be all these things added up, right? 6 plus 9 plus 9 plus 12. When I'm looking at the perimeter of a quadrilateral or a shape, I can multiply the perimeter times the scale factor will give me the new perimeter that I'm looking for. So in this case here, I have to figure out the scale factor. Now the scale factor of this guy, we're going from 6 to 2. So because we're going from 6 to 2, we are decreasing in size, right? So we're making a smaller version of what we had before. So I go from 6 to 2. So I can divide both sides by 6, I want to think of it that way, and I end up with 2/6 which is the same as 2 6 reduces to 1/3, my scale factor is 1/3. Alright, so that's my initial side is 1/3. I could do 1/3 of all of them and say, well, if I had a 6 and a 9 and a 9 and a 12, 1/3, or 6 times 1/3 is 2. 1/3 of 9 is going to be 3. 1/3 of this 9 is 3, and 12 times 1/3 is 4. And so my new perimeter will be the sum of all those parts. So I have 6 plus 4 is 10 plus 2 is 12 for my new area of quadrilateral B. Alright, let's look at the next page, page 3. Here's a polygon on a grid. It says draw a scaled copy of this polygon that has a perimeter of 30 units. What is the scale factor? Explain. Okay, so what we're going to do is the same idea before, is the perimeter had 10 units, and since the perimeter of a scaled copy is multiplied by the scale factor, which we want to find out, we need to figure out what that's going to be. So if I'm going to go from here, which has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, if I'm going to go from a perimeter of 10 to 30, I have to multiply by the scale factor. So what number times 10 will give you 30? That's your scale factor. In this case, it's 3, because 10 times 3 gives you 30. So that means I'll take each length, and I have a 3, a 1, a 2, a 1, a 1, and a 2, and multiply them all by 3. So I'll begin with my base, which was 2, and I'll make that into a 6. So we'll go 1, 2, 3, 4, 5, 6. My length was a 3, so I'm going to go to 9 now. 3 times 3 is 9. So that puts us at 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way to the top. 1 times 3 is 3. 1, 2, 3. 2 times 3 is 6. So 1, 2, 3, 4, 5, 6. And we're here. And then 1 times 3 is 3. 1, 2, 3. And 1, 2, 3 for our scaled copy there. Again, the key was I took my original perimeter times the scale factor gives me 30, and I knew that what times 10 gives me 30? 3, and I had to know my scale factor. And for your last question, it's one you have to write about and describe your own reasoning, so make sure you write a nice good sentence or two to explain your reasoning to discuss these figures. The first person, Priya, thinks that B and C and D are all scaled copies of A. This is our original. It's our original. Tyler says B and D are scaled copies of A. Do you agree with Priya or Tyler? You have to decide which one is correct. So again, a scaled copy, you're going to look for corresponding parts, right? Do they have the same shape? And also looking at angles. What's the scale factor as well? What's happening from one shape to the next? In this original, everything is 1, 1, 1, 1, 1 unit wide, long, however you want to look at that. In B, we go 2, 2, so we have 2's here, and 1's. Well, if these are all the same, shouldn't these be the same? Probably. Over here, we have 2, 1, 1, 2, so something's changing. And indeed, in D, we have 2, 2, 2, 2, 2, 2, all the way across. And so when you look at just what's happening in terms of the perimeter and the unit shapes, we can see there's a variety happening here. It might be growing one way as a scale version, but the other way not so much. Same for here. This one got a little too narrow, this one got a little too wide, and this one seemed to grow proportionally. So we'd probably want to say Tyler's looking pretty good, but explain your own reasoning. Hope that helps you out a little bit today. Good luck, and we'll see you next time.